This is Edexcel's GCSE Maths, Practice Set 5, Paper 2H. Question 1. Change 4.5 kilometres squared into metres squared. Well, 1 kilometre squared would be 1,000 metres by 1,000 metres. So we need to do 4.5 times 1,000 times 1,000. And that will give us 4,500,000 metres squared. Question 2. Carol and Delia share some money in the ratio 3 to 8. Delia gets £325 more than Carol. So that means the difference between these two numbers is worth £325. The difference between the two numbers is 5. So if we do 325 divided by 5, that will tell us what one part is worth. So one part will be worth £65. Carol gets 3 parts. So we need to do 3 lots of £65, which would be £195. Question 3. Sadie and Gohill are buying some petrol and some oil. Basically, this one is a simultaneous equations question, so we need to set up some simultaneous equations. So for Sadie, we've got 30 litres of petrol. Sorry, I'm going to use P for petrol. And 4 litres of oil. So I'm going to use a small O for oil. And that would give us £46. Gohill buys 24 litres of petrol and 8 litres of oil. And that would give us £45.20. Now, as it stands, neither of these have the same amount of petrol or oil in them, so we can change the first one. If we multiply the first one by 2, then we would get 60 litres of petrol and 8 litres of oil would equal £92. And then we can use that one because they've both got 8 litres of oil in. If we take these two away from each other, we've got 60p take away 24p, and that will give us 36 litres of petrol. The 8 litres of oil take away the 8 litres of oil is nothing. That was the whole reason for doing it. And 92 take away 45.20 is £46.80. So we can do £46.80 divided by 36. Sorry, £46.80 divided by 36. And that would give us £1.30 for a litre of petrol. We can then substitute that into either any of the equations that we've got. So I'm going to put it into the first one. So 30 lots of £1.30 plus 4 litres of oil would equal £46. So 30 lots of £1.30 is £39. And if we take £39 off both sides, we get that the 4 litres is worth £7. And therefore 1 litre of oil would be 7 divided by 4, which is £1.75. Question 4. The diagram shows 3 sides of a regular polygon. That means that all the sides must be the same. So regular means that all sides are the same. And a polygon is just a shape with straight sides, a closed shape with straight sides. Each interior angle is 150 degrees. Work out the number of sides. Well, the easiest way of doing this is working out an exterior angle. So an exterior angle is calculated by carrying one of the sides on and calculating this angle here. So that's 30 because angles on a straight line add up to 180. And we should know that all exterior angles add up to 360. So if we do 360 divided by 30, that will tell us the number of sides, which is 12. Question 5. Viv wants to invest £2,000 for 2 years in the same bank. And we've got 2 different banks there that she's looking at. Which one should she invest in, basically? So if we look at the International Bank, she will have £2,000. And for the first year, she gets a 4% interest rate. So to increase by 4%, we multiply by 1.04. The 1 keeps the amount of money the same, and the 0.04 is 4%. The year after, she will get 1.01. So that is a 1% increase. And that would give us £2,180. For the Friendly Bank, for the first year, she gets a 5% interest rate, so multiply by 1.05. And for the second year, she gets a 0.5% interest rate, so that would be 1.005. And if we put that into our calculator, we get £2,110.50. So she should choose the Friendly Bank. Question 6. Malcolm knows he eats too many biscuits. He wants to eat less than 30 biscuits in a week. On Monday, he eats some biscuits. So if we say that he eats X biscuits on a Monday, On Tuesday, he ate half as many. So if we say x divided by 2. On Wednesday, he ate 5 biscuits less than on Tuesday. So that would be x over 2 take 5. And on Thursday, he ate 9 biscuits. On Friday, Saturday and Sunday, he eats nothing. Malcolm ate less than 30 biscuits from Monday to Sunday. What is the biggest number he ate on Monday? Well, if we add these together, x over 2 plus x over 2 would make a full x, plus the other x gives us 2 x's, minus 5 and plus 9 gives us plus 4. And it says that he must eat less than 30 biscuits, so we can use less than 30. If we take 4 off both sides, we get 2x is less than 26, which means that x must be less than 13. Now, x was the amount he ate on Monday, and it's got to be less than 13, so we would put 12 as being the most he could eat on Monday. Question 7. In a sale, the normal price of a book is reduced by 10%, and the sale price of the book is £4.86. Calculate the normal price. Well, if we knew the normal price, which we don't, so we'll call it x, we would multiply that by 0.9 to get the sale price. So that's a reduction of 10% off 100%. And that will give us £4.86. So to work out the original price, we do £4.86 divided by 0.9, which would give us £5.40. Question 8. There are 80 singers in a choir. The cumulative frequency table gives information about the ages of 80 of the singers. You'll notice that the adding up has already been done for you here because all of the groups start at 20. So on the grid opposite, draw a cumulative frequency diagram. Thing to remember with a cumulative frequency diagram is that you always plot the end point. So for the first one, you'll be plotting 30, 2, and then 40, 15. Do this as accurately as you can. Try and use a ruler in the actual test. 50, 30, which would just be here. 60, 52, which would just be there. And then 70 and 80, which would be just up here. So as accurate as you can. With the cumulative frequency diagram, you always join these up with a curve. So a nice smooth curve to there. Part B, he says, use your cumulative frequency diagram to find an estimate for the median age. So there are 80 people in here, and the median means the middle. So we need to go to 40. Using a ruler, we go across at 40 and down to read off what the median age would be, and that is approximately 54. Part 2, work out the interquartile range. Well, if there are 80 people, a quarter of 80 is 20, so we need to go across from 20 and down to read off the lower quartile, which is approximately 43. 3 quarters of 80 is 60, so we'll go up to 60 across the graph and work out there, and that's approximately 61. So 61 take away 43 would be 18 for the interquartile range. It says find an estimate for the number of singers over 63. Well, a cumulative frequency graph always tells us how many people or less are in a certain group. So to do that, we need to go to 63, which is just here. Go up to the graph as accurately as you can, and across, and that's approximately 64. So that is 64 singers that are 63 or less. So because there are 80 singers altogether, we need to do 80 take away 64, which would be 16. Question 9. A rectangular lawn has a length of 3x meters and a width of 2x meters. The lawn and the path, the path has a width of 1 meter on all 3 sides. The total area of the lawn and the path is 100 meters squared. Show that 6x squared plus 7x minus 98 equals 100. Well, to find the area of this rectangle, we need to do the length times the width. So if this distance here is 2x, and we've got an extra meter here, this must be 2x plus 1. If this distance is 3x, and we've got an extra meter on either side, this must be 3x plus 2. To find the area then, we do 2x plus 1 multiplied by 3x plus 2, and that should equal 100, as we're told in the question. If we multiply that out, 2x times 3x is 6x squared, 2x times 2 is 4x, 1 times 3x is 3x, and 1 times 2 is 2, and that equals 100. If we make that equal to 0 by taking 100 off both sides, you end up with exactly what he's asked for, which is 6x squared plus 7x minus 98 equals 0. Part B, calculate the area of the lawn. So to work out the area of the lawn, we need to work out what x is. So on this one, I would use the formula for a quadratic. So the formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a would be 6, b would be 7, and c would be minus 98. So if we put that into the equation, minus 7 plus or minus the square root of 7 squared minus 4 times 6 times minus 98 all over 2 times 6, so 2 times a. If you put the bit under the square root into your calculator, you should get 2,401. So it's minus 7 plus or minus 2,401. Just be careful to make sure that you use a minus sign for the 98. And that would all be over 12. The square root of 2,401 is actually 49 when you put it into calculator. So this was probably factorisable as well. So that would be minus 7 plus or minus 49 all over 12. Obviously, if we do the subtraction, we end up with a negative number. We can't have a negative for a length. So we're going to just do minus 7 add 49, which will be 42 over 12, which will give us 3.5 for x. Now, we're after working out the length, the area of the lawn. So the width is 2x, so 2 times x, so 2 times 3.5 is 7, and 3 times 3.5 is 10.5. So we need to do 7 times 10.5, which would be 73.5 meters squared. Question 10. Here is a shape. It says work out the perimeter of the shape. Well, we've got a right angle triangle and a semicircle there. So in the right angle triangle, we need to work out this length here, AC, we'll call that x. Then we also need to work out P, which is the distance around the semicircle. So using Pythagoras, because it's a right angle triangle, we know that the hypotenuse squared, which is 8, is equal to 5 squared plus x squared. So to work out x squared, we need to do 8 squared take away 5 squared. So x squared would be 39. So x would be 6.24 and so on. Always write down your full calculator display, or just keep that in your calculator for later using the memory button. To work out P, the circumference of a circle is pi times the diameter. So in this case, the diameter is 8, so pi times 8. We've only got a semicircle, so we need to half that. So pi times 8 over 2, and that would give us 12.566 and so on. That is just two of the sides. We're also missing AB out here, so we need to add this together, plus the 5, which is it for AB. And if you add all those together to 3 significant figures, you get 23.8. Remember not to round until the last step. Question 11. Laura is raising money for charity. She has a game with 2 sets of cards. 80 students are going to play. Each student takes at random 1 card from each set and adds the 2 numbers together. They pay 70p a game, and she pays £3 if they win by getting a score of 9. Show that she could make a profit of £20. Well, there are 5 cards in set A and 4 cards in set B. So the total possible outcomes for this are 5 times 4, which is 20. The reason for that is you could get a 1 with either the 2, the 4, the 8 or the 9. You'll get a 3 with a 2, the 4, the 8 or the 9, a 5 with a 2, 4, 8 and 9 and so on. So that's 20 different possible outcomes. To win, you must score 9. So to do that, you could get a 1 and an 8, a 5 and a 4, or a 7 and a 2. So there are 3 different outcomes for that. So the probability of winning is 3 out of 20. Now, if there are 80 people going to play, 3/20ths will win. So 3/20ths of 80 divided by the bottom, so 80 divided by 20 is 4, times by the top, will give us 12 wins. Now, she will make 80 lots of 70 pence, and that would give us £56. And she would pay out 12 lots of £3, which is £36. So the profit that we should make is the difference between these two. So if we take those two away from each other, the profit is £20, as it asks us to show. Question 12. x equals 9 times 10 to the power of 2m, where m is an integer. Find in standard form an expression for the square root of x. So we want to find the square root of 9 times 10 to the 2m. Well, to find the square root of something, the square root of 9 is just 3. And the square root of something to the power, you just half the power. So we'll multiply that, by 10 to the power of m. So half of 2m would just be m. So it's 3 times 10 to the m. It says y equals 9 times 10 to the 2n, where n is an integer. Find in standard form an expression for y equals, y to the power of 3 over 2. Well, that means cube it and then square root it. So we've already done the square rooting bit, so we know that the square root of 9 times 10 to the 2n would just be 3 times 10 to the n. And then if we want to cube that, we want to cube each of those parts. So 3 cubed would be 27, and 10 to the power n cubed would be 10 to the power 3n. Now that's not in standard form, because the standard form needs to be a number between 1 and 10. So if we change that to 2.7, we would need to add 1 to the power of that. So that would be 10 to the power of 3n plus 1. Question 13. The diagram shows a triangular prism with a horizontal rectangular base ABCD, and then it gives you a lot of information which is already on the diagram. Calculate the size of the angle between TB and the base ABCD. So TB is this here, and the base is going to be there. So we're after this angle here, x. And if once you've drawn that side in, you can see we've got a right angled triangle. This M is the midpoint of that side, and DA is 7 centimetres. So this here, from A to M, would be 3.5 centimetres. So we can use Pythagoras twice here. We can work out the distance from M to B. So to work out MB, that is the hypotenuse of that triangle. So you just do 10 squared plus 3.5 squared. That would give us 112.25. And then to work out MB, we just square root that. And that would give us 10.59481. So this distance here is 10.59481. Now, we've got a right angled triangle there with one side that we know and an angle that we're after, and we also know this side here. So we've got two sides and an angle, so we can just use trigonometry. Now, this is the opposite, and this one is the adjacent. So using the opposite and adjacent from SOHCAHTOA, we can see the opposite and the adjacent are using tan. So we're going to use tan x equals the opposite, which is 6, over the adjacent, which is 10.59. Again, don't round, make sure you use the full calculator display in there. So to work out x, you would do inverse tan of 6 over 10.59, again using full calculator display, and that would give us 29.5 degrees to 1 decimal place. Question 24. The length of a rectangle is 35 centimetres correct to the nearest centimetre, and 26 for the width to the nearest centimetre. So as soon as we see to the nearest something, we are doing bounds. So the bounds of the length is 34.5 up to 35.5 because it's to the nearest centimetre, and for the width it's 25.5 to 26.5. It says calculate the upper bound for the area of the rectangle. Well, the area of the rectangle is length times width, and if we want the upper bound, we want the largest possible area, so we want to use both upper bounds for this. So we want to do 35.5 times 26.5, and that will give us 940.75 centimetres squared. Question 15. F is a function such that f of x is 1 over x squared plus 1. Find f of a half. Well, to do this, you would just do 1 over a half squared plus 1. You can put that straight into calculator, but we know that a half squared is a quarter, so that would be 1 1/4 on the bottom. So it's 1 over 1.25, which will give us 0.8. G is a function such that g of x equals the square root of x minus 1. Find f of g of x. This just means put g of x into f of x where the x is. So I'm going to write out the original f of x, but where the x was, I'm going to put x minus the square root of x minus 1. That was squared because it was squared in f of x plus 1. Now, if we're squaring a square root, those will just cancel out. So we end up with x minus 1 plus 1, so that would just give us 1 over x. Question 16. An athlete is running a race. The diagram shows a speed time graph for the athlete. Work out an estimate for the acceleration of this athlete at 3 seconds. So 3 seconds is just here. If we go up to the graph, we're after the acceleration just at this point here. If we draw a tangent to the line, the tangent, obviously use a ruler for this, but it should go approximately like that. Try and use a ruler and get it as accurate as you possibly can. You'll see that to work out the gradient of this, which is what we're after, we do the change in y divided by the change in x. So the difference in y divided by the difference in x. The difference in y goes from 14 down to 3. So 14 take 3, which is 11. And the difference in x goes from 5 here down to 0. So 5 take 0 is just 5. 11 over 5 would be 2.2 meters per second squared. The athlete ran the race in 10 seconds. The area under the graph gives the distance the athlete ran in the 10 seconds. Show that this race could have been a 100-meter race. Well, to work out the distance that they ran, you need to work out the area under the graph. So to do this, I'm going to split it up into chunks. So we can get quite a nice triangle here. We'll call that A. We can get a trapezium here. Again, it's a slight underestimate there, so we should be getting an answer just less than 100. And we can get another trapezium just here. We'll call that C. And then at the end, we've got a nice big rectangle. We'll call that D. So to work out the area of A, you do base times height and half it. So 7 times 2 and half it, which is 7. So that's the area of A. To work out B, you need to add the two parallel sides together, divide by 2, and then multiply by the distance between them. So the two parallel sides are 7 and 11. So we add those together and half it, multiply by 2, the distance between them, and that will give us 18. For C, again, it's a trapezium, so we add together the two parallel sides, so that would be 11 plus 12 over 2, times by the distance between them again, which is 2, so that would give us 23. And then for D, it's just a straightforward rectangle, so that would be 12 times 4, which is 48. And if we add all those together, the sum of these equals 96. So you could tell from the trapeziums that we're looking at, this is a slight underestimate. So as this is a slight underestimate, it would have been a 100-meter race. Question 17. Rhodri is investigating the population growth of the rabbits in an enclosure. He counted the number of rabbits at the start month 0. He counted the number of rabbits at the start of month 2. Here is his results. The population of rabbits is increasing exponentially. How many rabbits will there be at the 5th month? Well, to be increasing exponentially, all this means is that it will go up by a multiplier each month. So at the start, there were 100 rabbits, and to get to the second month, to get to the first months, you would multiply that by a common multiplier x. To get to the end of the second month, you would multiply by that multiplier again, so x squared, and that will give us an answer of 200. To work out what that multiplier was, we just need to rearrange that to find x. So if we divide by 100, we get x squared equals 2. So x must be the square root of 2. To get to the 5th month then, we just need to start off with the original amount of rabbits, multiply that by the multiplier, which is root 2, 5 times, so to the power of 5. And that will give us 565.68 rabbits. So rounding that up, that would be 566 rabbits. Question 18. OAB is a triangle. OA is A, OB is vector B. Find the vector AB. So we're trying to get from A to B along vectors that we know. So if we start at A, we can go down here. So that would be a minus A. And then along here, which would be A plus B. P is the point on AB such that AP is to PB is in the ratio 3 to 2. Show that OP is a fifth of 2A plus 3B. Well, to get from O to P, we can go up here and then down here. Going from along O to A, so that's OA plus AP that we're after. OA is just A, and we need to add to that AP. Now AP is in the ratio 3 to 2, so that would be 3/5 of the vector AB, which we've already worked out in part A. So that would be 3/5 of minus A plus B. If we expand that out, we'd have A plus minus 3/5 of A plus 3/5 of B. Now A take away 3/5 of A would just be 2/5 of A. So that can simplify to 2/5 of A plus 3/5 of B. And if we pull a common factor out of that, of the fifth, then that would give what we're after. So that would factorise to 1/5 of 2A plus 3B. Question 19. Prove algebraically that 2n plus 1 squared minus 2n plus 1 is an even number for all positive values of n. So if we expand that out, 2n plus 1 squared means 2n plus 1 times 2n plus 1. And then we're going to take from that 2n plus 1. Expand this using FOIL. So first is 2n times 2n is 4n squared. Outside is 2n times 1 is plus 2n. Inside is 1 times 2n is another 2n. And 1 times 1 is 1. And we're going to take from that 2n's. We're going to also take from that 1. So it's 2n minus 1. That's the key bit that people get wrong. If we subtract in the second bracket, both terms will change signs. So if we simplify that out, a 2n will cancel with a minus 2n, a plus 1 with a minus 1, and we're left with just 4n squared plus 2n. To prove that that's an even number, we need to pull a factor of 2 out. So that can factorise to 2 brackets, 2n squared plus n. Therefore, it must be an even number.